Hello, class. I'd like to answer a few more questions from your homework. For the first question, it looks like it asks to determine the histogram that has the greater standard deviation. So really, the greater the dispersion, the greater the standard deviation, right? So the more your data is spread out, the greater the standard deviation. So if you look, from here, my data looks like it goes from 40 to 60, right? Difference of 20 versus 30 to 70, maybe even 75 or so, some number greater than 70. So it looks like my data is more spread out on this graph B. So there's more dispersion on graph B, so the standard deviation is going to be higher. So histogram B, nope, so this one is not correct. Histogram depicts a higher standard deviation because the bars are higher than average bar. No. Oh, here we go. Histogram B, that's this one, has a higher standard deviation because the distribution has more dispersion, right? My data is more spread out. There's a greater spread. I press check answer, looks good. Let's go on to the next question, number 10. All right, this looks like a 5-part question. So we have a bunch of candy, right? Different candies, and looks like they have different weights, right? So each candy is not exactly the same, right? Maybe think of like chocolate, coconut or caramel clusters with nuts, right? Maybe you grab this batch and you're making these clusters, but you try to make them all the same size, but maybe they're different sizes and different weights. So first thing we ask for is the standard deviation. So I open up my table in StatCrunch, right? StatCrunch is my best friend here. I press Stat, Summary Stats from columns. My data is in column bar 1. And I think this should do it. I press compute, and here is my standard deviation. Okay, so 0.0686. It says go 2 decimal places, so I think we're going to have to round 0.07. Let's enter that. Check our answer. So far, so good. Next, we have a histogram on the right, and it says, can we use the empirical rule to make general statements about the weight? And yeah, because this is bell-shaped, right? We have a standard normal curve. It looks like a bell. We can say the histogram is bell-shaped, so we can indeed use the rule. I checked my answer. Great job. Next, okay, so it says use the rule to determine the percent of candies between 0.7 and 0.98. So it's important to realize that, remember, the mean was 0.84, right? If I were to find the average of the mean for all of these numbers, I'd get 0.84. So one standard deviation would be 0.84 plus 0.07, right? So if I do my calculator, 0.07 plus 0.84, you could say one standard deviation would be 0.91, but they're looking for 0.98. So I have to add plus 0.07. So I had to add 2 standard deviations. Remember, my standard deviation was 0.07. So I added 0.07 twice to 0.84 to get 0.98. And if I were to subtract, right, if I took 0.84 and subtract 0.07 2 times, right, that would take me 2 standard deviations to the left, which is this 0.7, right? So 0.07 added twice to my mean gives me 0.98. 0.07 subtracted twice from my mean gives me 0.7. So here's a table that tells you, okay, so according to our rule, one standard deviation away from our mean, right? So our mean is this middle line. And if you were to go 1 standard deviation away in either direction, you'd add the 34% plus 34%. So 68% of your data would be between 1 standard deviation from our mean. But we are looking to go 2 standard deviations, right? So we have to add this the 34% twice plus this 13.5%, right? If I go in this direction, here's my mean, 1 standard deviation, 2 standard deviations away. You add that, and to the left, you would add 1 standard deviation and 2 standard deviations, which would be these two numbers. So if you add the 34%, right, let's just do 34 plus 34, right, that's this number, plus 13.5 twice, right, plus 13.5, you see we get 95, or 95%. So 95% of our data, or our candy, right, the weights of our candy, would fall in between 0.7 and 0.98. We get an excellent. Let's keep going. Now it says, all right, well, that was what the rule says. It would predict. But what's the actual percent, right? So if I go back to my MyStatLab, or StatCrunch, right? Let's get rid of this. So remember, my data from the table that we were given, having trouble resizing. There we go. I want to rank this in order from smallest to largest, okay? So if I press data, sort, variable 1, that's where my data is stored, right? Sort by variable 1. Okay, so my lowest value is 72 or 0.72, and my greatest value is 0.99. And we want to know, oops, let's just close that out. All right, so we want to know how many of my candies fall between 0.7 and 0.98. So you would have to actually calculate, here's 0.7. So basically all of these, right, this is greater than 0.7, and we go all the way to 0.98. So basically everything except these two, right? So that means if there's 50 candies, 48 out of 50, right? 48 of my candies out of 50 are 0.98 or lower, right? And just make sure that's what they're asking. Yeah, fall between 0.7 and 0.98. I press enter, and it looks like I get 0.96. So let's put that in, and I get the nice work, right? Again, I want to make sure, right? I had 0.96, but as a percentage, we moved the decimal 2 places to the right to get 96%. Okay, so now it says, all right, determine the percentage of candies with weights more than 91%. So I have to bring back my chart here. So 91% is 1 standard deviation away, right? Because remember, my standard deviation was 0.07, my mean was 0.84. So 0.84 plus 0.07 is that 91, right? Or 0.91 grams. So 1 standard deviation. I want to know how many of my candies are greater than 1 standard deviation away. So that would be the 13.5 plus the 2.5. I have to add all of these values up. So let me do that. All right, so if I add the 13.5 plus the 2.5, that covers all of this part of my curve. So it looks like only 16% of my candies will have a weight greater than 1 standard deviation away. So I'll put in 16%. I get a good job. And then it says, all right, now give me the actual percent. So the actual means I have to look at my raw data from this table, which we have in StatCrunch. And I want to know how many of these are greater than 0.91. So it looks like if I have 50 candies, basically from here to here, right, from 41 to 50. Right, so it looks like this would be 10 candies, right? If you were to count 1, 2, 3, oops, let's try that again, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So 10 values have a weight that's greater than 0.91 grams. So you have to divide, right? As a percentage, it's 10 out of 50. So I do 10 divided by 50 to get, looks like 0.2, right? So maybe we'll call that 20%. And I press enter, and I get the good job. So I hope you find that helpful. Thank you for watching.